statistic for nominal data. Presume that you observe 100 people to see who deposits garbage in the can and who litters, and you want to see if there's a difference based on gender. This is categorical data, or nominal data, because a person can fall into one of four categories: a male who deposits the garbage, a male who litters, a female who deposits the garbage, and a female who litters. After you do your observation, you find the following data. So given this data, is there a significant difference in littering behavior between men and women? To answer this question, you have to figure out what numbers you might expect if everything were left to chance. That is, if the null hypothesis were true, that there is no difference based on gender. In that case, you would expect the responses to be equally distributed through all the possibilities. So since 60 people deposited their garbage, that's the total for this column, and 25% of them were female, you would expect, by pure chance, 15, or 25% of 60 females to be in this value here in the upper left cell. Again, that's if there's an equal distribution with no effect of gender. Similarly, because 40 people did litter and 75% of them were male, you'd expect 30, 75% of 40, to be the value in this lower right cell if there's no gender effect. Working in a similar method, you can fill in all the expected values. The further these observed values are from the expected values, the more likely that there really is a significant difference, that there really is an effect of gender. So now we have to have a formula for computing the chi-squared statistic. And the way we'll do this is for every cell, we'll take the observed number and subtract the expected number, square that, and divide by the expected number. So it's the sum over all the cells of the observed minus expected squared divided by the expected value. In this case, it works out to 18 minus 15, or 3 squared divided by 15, plus 7 minus 10 squared divided by the expected value of 10, plus 42 minus 45 squared divided by 45, plus 33 minus 30 squared divided by 30. And if we add all those up, we get a total of 2.0 for chi-squared. If you look up 2.0 in the chi-squared table with 1 degree of freedom, you'll find that the probability of this result is 0.16, so you retain the null hypothesis. There's no significant difference in littering or garbage depositing behavior based on gender. We'll talk a little bit later about how that degrees of freedom was calculated. Here's another experiment. In this experiment, you publish flyers in 3 different colors and see how many people take them or don't take them. Is there a significant effect based on color? And here the table shows the observed values. Notice that you don't have an equal number of flyers of each color, but that doesn't matter. You can still calculate chi-squared. To find the expected value of a cell, you multiply the row total, in this case 90, times the column total, which is 40, and divide by the grand total, in this case 150. So for the upper left cell, you get an expected value of 24. The next cell in the top row has an expected value of 90, the row total, times 60, its column total, divided by 150, the grand total, which works out to 36. Proceeding in this fashion, you can fill in all the remaining expected values. You could also just use subtraction since you know what the totals have to be. For example, the first row adds up to 90, and we already have calculated 24 plus 36, which comes out to 60. Therefore, we know that this last cell must have a 30 in it. In fact, you could compute all the rest of the values after you fill in those first 2 items, and that means that this design has 2 degrees of freedom. In general, the number of degrees of freedom for chi-squared is the number of rows minus 1 times the number of columns minus 1. And in this case, that's 1 times 2, or 2 degrees of freedom. If we apply the formula for chi-squared, again going over every cell, taking the observed minus the expected and squaring it and dividing by the expected value, the result is 15.28, and when you look that up in the table with 2 degrees of freedom, the probability is less than 1 in 1,000.
Okay, time to compute the actual chi-square test. You could do this next step a lot of different ways, but here's the way that I found is will keep you from getting confused. I'll come in here to the pivot table and highlight all of this information right here. The labels at the top of the columns, the labels in the rows over here, and what we call the marginals, the grand totals here of the columns and the rows. Highlight all of that. Right click, choose copy, come down right below it, right click and choose paste special and paste those values. Alright, so all I did was I just duplicated, hit escape here, duplicated down here the values in the table up here. And that'll keep me on track here, because what I'm going to do is I'm going to compute expected values here and contrast those expected values with the observed values up here in the actual table. To do the expected values, I'm going to hollow this copy out. I'm just going to highlight the values here, click delete. Alright, and I'm going to just label this as well, expected, so I'll be able to keep this straight. Alright, so the expected value now for minorities with minority neighborhoods and cleared cases would be, I'm going to write a formula here, start with an equal sign. I need to take the total at the bottom of the column, the 15, and multiply it by the grand total in the row here, the same row is cleared, 17, and then divide by the grand total, the 30, just like that. So that's the pattern. This times this divided by this. Click enter. I'm going to do the same thing for this cell, equal. Again, the column total times the row total divided by the grand total. Alright. Same thing for here. This times this divided by this. And finally, this times this divided by this. Here we go. So there are our expected values. Now notice that because our two sample sizes are identical, 15 minority neighborhood burglaries and 15 white neighborhood burglaries, these values are the same as well. 8.5 here, 8.5 here, 6.5 here, 6.5 here. If your two group sizes are different, then obviously these values have a pretty good chance of being different as well, and that's perfectly okay. Alright, so the final step now is to use the chi-test in Microsoft Excel to contrast the observed values up here with the expected values down here. And it looks like this. I'm just going to give it a p-value, like that, or p to let myself know what this value means, and then type the formula, equal chi-test, C-H-I-T-E-S-T, and then a left parenthesis. And I need to start by highlighting the actual range, the range of observed values, and then a comma, and then the expected values, which I just computed, and then a right parenthesis and enter. And here I get a probability level. It is, as you can see, 0.0099067774. The thing to look for is this value less than 0.05? And this one is quite a bit less than 0.05. So what that means is that the differences that we see in clearance rates between minority neighborhoods and white neighborhoods is not just due to randomness, or not due to the fact that we're looking at 30 randomly sampled cases rather than all of the cases. It is in fact a real pattern in the population of all burglaries in minority and white neighborhoods. So that's how to figure a chi-square test in Microsoft Excel.